content before the test, but we're going to spend a lot of time pulling all this together. So we have something called the rational root theorem. And it says this: if you have a polynomial, p of x, and they have integer coefficients, so that means not fractions or decimals, okay? So if it has integer coefficients, then every rational root of the polynomial equation, p of x equals 0, can be written in the form p over q, where p, and I'd like you to use your highlighter here, p is a factor of your constant term, and q is a factor of the leading coefficient. Now it does say make sure to factor out the GCF before evaluating possible rational roots. It just makes your life easier. All right, so P is 20 and Q is 8, okay? 20 is the constant and 8 is the leading coefficient. Or I guess that's not P, those are, let me erase that a second. Here, let me restate that. So 20 is the constant term, and 8 is the leading coefficient. Let me restate that. So now, I'm not looking at capital P, I'm looking at lowercase p, and I want to think about what are all the factors of 20. So 1 times 20, but couldn't I also have negative 1 times negative 20? I could have 2 times 10, I could have negative 2 times negative 10. I could have 4 times 5 and negative 4 times negative 5. So watch how I'm going to write the possible factors. I'm going to do plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Let me go over that one more time. P is a list of all the factors of the constant term. So 1 times 20, negative 1 times negative 20. 2 times 10, negative 2 times negative 10. 4 times 5, and negative 4 times negative 5. I could have any combination of those. So now, if Q is 8, can you come up with the list of factors using the plus or minus? To give you about a 30-second head start on me. What would be the factors, all the possible combination of factors of 8? Yeah, factors are what multiply together. All right, anybody got it? Anybody want to share? Yeah, baby. Good job, you got it. All right, so now the rational root theorem says the possibilities. Okay, it's not saying these are the answers, but these are all the possible rational roots. Is you would take all the combinations of P factors divided by Q factors. And once you get the hang of this, this is not bad at all, but at first it's a little bit weird. So first of all, if I took all the P factors and put them over 1, what would result? The same numbers, right? Okay, if I take all the P factors and I divide them by 1, or even negative 1, it's going to produce the P row, correct? So we're going to write those down first, and that'll always be your first list. Now you're not going to write numbers that overlap, like that you've already written down. So now I have to take all the p-values and divide by 2. And then we're going to write down any new ones that we don't have. So do we have 1 over 2 yet? No. So we've got to include 1 over 2. And we're going to do plus or minus. Do we have 2 over 2 in the list? Yes, because that's 1. Then I'll take 4 over 2. Do we have that one? Yes. Do I have 5 over 2? No. Okay, so we've got to add that one. Oops. Oh, there it is. Where'd it go? How about 10 over 2? Do we have that one? What is 10 over 2? 5. Yeah, we have that one. And how about 20 over 2? Yeah, we've got that. All right, now we're going to put them all over the 4 and write down just any new ones that we don't have. Do we have 1 over 4? No. Okay, so we got to include that one. Do we have 2 over 4? Yes, we have 1/2. Do I have 4 over 4? Yes, I've got 1. What do I have 5 over 4? No, so I've got to add 5 over 4. Do I have 10 over 4? Yes. Do I have 20 over 4? Yes. Okay, now we're going to go through and do it all over 8. Do I have 1 over 8? No, so we've got to add that one. Do we have 2 over 8? Yes. Do we have 4 over 8? Yes. Do I have 5 over 8? No. All right, do I have 10 over 8? Yes, that's 5/4. And do I have 20 over 8? Yes. Okay. So this is my list of possible rational roots. So what I mentioned yesterday is sometimes you're not given one of the zeros, and we have to come up with them. In my AP Calculus class, we have had that, where you're given nothing, and it isn't going to factor by grouping, and so we have to use this. All right, so let's write this down. 6 is the constant term. 3 is the leading coefficient. So I'm going to give you a brief head start. P is going to be all the factors of the constant term, and Q is going to be the factors of the leading coefficient. So go ahead and list all the plus or minuses to those. If you're really getting the hang of it, do P over Q. When you're ready, check the board. I have P would be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Because P are the factors of the constant term. Q would be plus or minus 1, plus or minus 3, because Q are the factors of the leading coefficient. Now look at what we did for P over Q. So you're going to have to write all of the P's down because they go over 1. And then find the ones that we don't have when you take the p-values over 3. I'll give you about 60 seconds head start on me. All right, then I don't have the 1/3. I don't have the 2/3, but I do have 3/3 is 1, and I have 6/3 is 2. Give me thumbs up. How many of you got that okay on your own? Awesome. All right, so now that's listing the possibilities. Now we're going to transition to, okay, who cares? Like, why did we do that? So oftentimes, like, we build foundations to use and apply somewhere else. So here we go. It says find all the zeros. So there's no way to factor this one. So P is plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Q is just plus or minus 1. So P over Q I didn't want that. Is just the P values, right? Because Q was 1. So now here's what you do with that information. You start with 1 and you plug it in. And we want to see if 1 is a 0. So wouldn't that be 1 plus 1 plus 2 plus 4 minus 8? Hey, that's a 0, right? I got 1. Let's try negative 1. That would be 1 minus 1 plus 2 minus 4 minus 8. That doesn't work. When I do P of 2, that's what, 16 plus 8 plus 8. Well, that's definitely not it, right? That's definitely not 0. I don't care what it is. It's just not 0. But P of negative 2 is 0. So really this is a pain. This is kind of a pain to do these. But watch what we're gonna tie this all together. It's really quite beautiful. Is I found 2 of the zeros. And the reason why I'm stopping here, yeah, baby. Negative 1 to the 4th. Wouldn't that be positive? Yeah. Good question, though. So here's the deal. If I can do synthetic division twice, I can take this from x to the 4th down to x squared, and then I can handle it. So that's why I only need 2. And if I have an x cubed, I can do the same thing. So watch what I'm going to do. I'm going to put 1 in the box. And I'm going to give you a quick head start on me and go ahead and do the synthetic division. And once you get that bottom row, let's stop. Because then what we're going to do, we talked about this previously, we're going to do what's called a depressed polynomial and take it down from that row to get it directly to a quadratic. It's a great question. Do you understand that when I do this first synthetic division, this bottom row is going to be an x cubed, right? And then when I do the next one, I'm going to take this one and take it down again to an x squared. I know how to handle all x squared. It'll either factor or quadratic formula. If this had been x cubed, I only would want one of them to get it down to an x squared. Okay? Great question. So I bring down the 1. That's a 2. All right, so it's nice because that did go in evenly, which it should have. All right, now I'm going to take the next one with this depressed polynomial because now that's x cubed, and I'm taking this down to an x squared. So that's x squared plus 4. So that's x plus 2i times x minus 2i. And then don't forget about the other ones we found. X is 1 and x is negative 2. So there were 4 zeros, and it was a 4th degree polynomial. So do you see where I have x squared plus 4? Okay, so I'm looking for a sum and difference, but when I add the, when I do that last, so the outer and inner have to cancel, and then 2i minus 2i is 4i squared, and it's a minus 4i squared. And what do you know about I squared? It's negative 1, so that'll pop this to a plus 4. Yeah. Okay, great question, and that's circling back to what Keelan had asked. You see this is 4th degree? So if I do the first synthetic division, I went from a 4th degree to now a 3rd degree. And then when I did it again, that took me down to an x squared. I could go try the other ones, but you see none of them would work because these were imaginary. But if I can get it to a quadratic, I know how to handle all the quadratics. So like what I mentioned is if this had been an x cubed, I would only want to go find the first one. Do the synthetic and get it to x squared, and then I know how to do it. Because these are a pain to have to go check them all, you know? So I'm going to do the least number possible is the goal. All right, so here, P would be plus or minus 1, plus or minus 3. Q is plus or minus 1, and plus or minus 2. So the rational root theorem says you're taking all the combinations of P over Q. So that'll be plus or minus 1, plus or minus 3, then plus or minus 1/2, and plus or minus 3/2. Just because of time, P of 1 is 0, and P of 3 is 0, okay, just because of time. On the homework, I only ask you to do 2 problems like this because they are time-consuming, so I just put 2 of them on the homework. So watch what we're going to do. We're just going to repeat this. I'm going to put 1 in the box. Let me give you a little head start. Do this synthetic division. Then when you're done, take the second 0, which is a positive 3, and take the depressed polynomial down. Yeah, Angela? Great question. It does not matter if you start with the 3 or the 1. You will eventually get down to this, the middle part of your work will look different, but your quadratic will be the same. Yeah. All right, I'm going to go ahead and do this one. I'm going to bring down the 2. Okay, now I'm going to use the 3 with this depressed polynomial. So like this one resulted in an x cubed, and this one's going to result in an x squared. That's what I mean by that. All right, then you're getting 2x squared plus 3x plus 1. So this one factors. I'll pause and give you a head start. See if you can factor this one. So the 6-4, worksheet number 4 is due tomorrow, okay? Thank you.
Yep.
Thank you. Yeah, otherwise you're going to lose that. All right, let me go ahead and work this one out. So you're looking for two numbers that multiply to 2 but add to 3. So that's going to be a 2 and a 1. So I do 2x squared plus 2x plus 1x plus 1. So that's 2x times x plus 1. Here they have nothing in common besides the 1. So I get x plus 1 times 2x plus 1. So x plus 1 is 0, 2x plus 1 is 0. Now, on an answer blank, if you put that in, I'm going to mark it wrong because don't forget about the first two that we found with the rational root theorem.